Hello, this is a video on stoichiometry. Basically, stoichiometry is the application of the mole wheel through a chemical reaction so that instead of just being able to explain one substance, now with the balanced chemical reaction and its coefficients, once you know information about one of the reactants or products, you can know information about all of them. So this is the main web page, and there is a stoichiometry wheel like the mole wheel. So there's only basically 3 steps. Besides, after balancing the chemical reaction, so if you consider that 1, there's 4. You need a balanced chemical reaction because you want the coefficients. That's the important part. So what you do is, once you have the coefficients, you have a known substance and you know something about it. So the first thing you do is change that known information to moles of that substance. And now the new thing is, the next step is to take and change the moles of that substance, and you want to change it to the moles of the new substance you want to look at. That is done by what is called a mole ratio, which comes from the coefficients in the balanced chemical reaction. And once you do that, you have the moles of the substance you're looking for, and then you can take the moles of the substance you're looking for and change it into whatever they're asking about, massing, voluming, things like that. And that's the last step. And that's what these 4 things for, because you have to balance the chemical reaction to get the coefficients first. There's a little picture here. So this is kind of like the mole wheel extended. Okay, here's one mole wheel, the substance you know. Here's the mole wheel of the substance you're looking for, and the link between them. I put a bridge, bridge between things, kind of, is the molar ratio. So of course, what you would do with this is you would say, oh, I know the mass of X, Y, Z, and I'm looking for the volume of this one. So you change the mass to mole using your mole wheel, and then the new thing is the molar ratio. And the molar ratio is a ratio of moles, and it's always the moles of the substance you know about with its coefficient from the balanced chemical reaction in front of it, on the bottom. And then on the top is the moles of what the substance you're looking for and its coefficient that's in the balanced chemical reaction. And that will take you from the moles of what substance you know to the moles of the substance you're looking for. And then you change the moles. Now it's another mole wheel, and you go, in this case, we go to volume. Okay, and that's what you do every single time, unless they ask you to stop between them, as in, oh, I just want to know the moles, not the volume, or something else. But those are the 3 main steps. And that's what these main steps are. And I believe that's what what these steps here mean too. So looking at it as an example, so this is a standard view of a question in stoichiometry. How many grams of nitrogen gas is produced if I react 32.5 grams of ammonium gas? And the big thing is, you see it says using following chemical equation. They have to give you a balanced chemical equation or make you figure it out to be able to do stoichiometry. So that's the key to know you're doing stoichiometry. So in this case, you do the 4 steps. You got to make sure you get a balanced chemical reaction. It's right here. You have it. Then the next thing you need to do is you kind of need to do the roadmap, which is, I have grams of ammonia and I'm looking for grams of nitrogen. So the first thing I'd have to do, and it's done down here, I do it by dimensional analysis first, then I do it by equation. But let's just kind of write it out. I'm going to take the grams of ammonia, change it into moles of ammonia. Okay, that's just a molar mass calculation. Okay, you need the mole mass, and that's a mole calculation. This is the new thing, this one right here. You want to go from the moles of NH3 to the moles of N2. You have to set up the right molar ratio. It is exactly what it says. It's right here. It's a molar ratio. You're trying to get rid of moles of NH3 and you want to go to moles of N2. This 5 and 4 comes directly from the balanced chemical reaction 5 and 4. That's why you have to have a balanced chemical reaction. And once you do that, now you have this whole bit right here is you have moles of N2, and then when you don't want moles of N2, you want grams of N2 because they ask for it. So therefore, this is your answer, and that's the answer with the right number of significant figures. And the same exact thing you would do, here's your balanced chemical reaction, and the only difference here is you're going to by equation. So you equation people, it's a massing equation, okay? That's equation straight up. You know the molar mass. You do this, you get so many moles of NH3. That's old. That's regular mole, one-step mole calculation. And here's the new stuff. You set up your molar ratio. See, you have moles of NH3. So you write moles of NH3. And you want to go as a moles of N2. So here you write moles of N2. And you know you know the coefficients because you come up here and NH3, there's a 4, and N2, there's a 5. That's where they come from. And you don't reduce them. You keep them the way they are so you can show that's what they are. And you get moles of N2, but you don't want moles of N2. So that's the only new part. Then, of course, now you just simply do another mole wheel, one-step calculation. You want grams, so you then modified the equation. You know what the molar mass is for N2. Here you go. And you get your answer. Okay? Same exact answer. So up here, you have to do the molar mass of both of them too. I just didn't show it here. So that's it. That's stoichiometry. Okay? It's basically, if there's a balanced chemical reaction or they're asking you for a balanced chemical reaction, there's a huge probability that you're doing stoichiometry. Okay? I hope that helps, and ask questions if you don't.